Hello friends, in this tutorial we are going to learn about asymptotic notations. The various asymptotic notations are big O, big omega, big theta, and we have small o. Small omega is represented like this, small omega. So big O notation, how we do? So let's consider two functions, that is f of n and g of n. And f of n is equal to big O of g of n when we say this is if and only if this f of n is less than or equal to c into g of n, and where c must be greater than 0 and this n must be greater than n naught and this n naught must be greater than 0. These are the conditions. So we have a graph for this. There is n and this is time. On x-axis we take n, y-axis we take time. So if f of n goes like this, then c into g of n goes like this. This position is n naught. So big O notation always represents the upper bound. And big O notations are used for the best case. That is the best case time complexity. So let's consider a problem. What is this f of n less than or equal to c into g of n? So let's take f of n equal to n, g of n equal to 5n. And we need to prove that f of n is big O of g of n. Here f of n is n less than or equal to c into g of n we need to prove. So n is less than or equal to c into 5n. So we need to make this c in such a way that it must be greater than 0 and it must satisfy this condition. Then only we can prove that f of n is equal to big O of g of n. So how we do? If we take c equal to 1, then n is less than or equal to 5n. If c equal to 2, then n is less than or equal to 10n. So the condition is satisfying. So here the c is greater than 0. It is applicable. So it is proving it. Now let's take big O of omega. Big O of omega. Big O of omega, it represents lower boundary. That is nothing but it defines the worst case time complexity. So how do we represent this? This is time x. So it is f of n. Then c into g of n will be at the bottom because it is lower bound. And here we will take f of n, g of n, two functions. F of n is said to be big omega of g of n if f of n is greater than or equal to c into g of n. In big O it is less than or equal to. In big omega it is greater than or equal to. For some c greater than 0, n greater than or equal to n naught greater than or equal to greater than 0. So let's consider a problem for it. Let f of n equal to 5n plus 10, g of n equal to 2n. So 5n plus 10 greater than or equal to c into 2n. We need to make this greater than this. So here we consider c equal to 1. So 5n plus 10 greater than or equal to 2n. And when we take this 2n this side, it will be 3n less than or equal to 10. Or whatever. But here we are getting this is greater than this. Or 3n if we take 1, 3 is less than or equal to 10. N if we take 1, 2, 3 till n equal to 3, n less than or equal to 3, it satisfies. So let's consider another example. Let f of n equal to n square, g of n equal to n square plus n. So n square greater than or equal to c into n square plus n. So let's take n square same plus n means it will become greater, but we need to make this as a greater one. So what we do, we take c equal to half. So n square greater than or equal to half into n square plus n. Now n square greater than or equal to half n square plus half n this is half n square plus half n. So if we take this n square as like this, half n square plus half n square, it will be n square 2n square by 2. 2 cancels, so it will be n square. So what we do, we make this n square as half n square plus half n square greater than or equal to half n square plus half n. So we cancel one of this. So half n square is greater than or equal to half n. Now this is greater, n square is greater than n. So it satisfies the condition f of n equal to BigO of g of n. In this way we can prove this. And next we have BigO of theta. BigO of theta. Here it is a combination of both BigO and big omega. It is BigO and big omega. That is, BigO is for best case, big omega is for worst case, this is for balanced, that is average case. So what we have, c1 g of n less than or equal to f of n, it is big omega. c1 g of n greater than or equal to f of n, this is BigO. Or we can write like this as we did before, f of n greater than or equal to c1 of g of n this is big omega. If f of n less than or equal to c2 of g of n, this is big O. So now let's consider an example. F of n equal to n square plus n, g of n equal to 5n square. Now we need to prove that f of n is equal to big theta of g of n. So first let's prove the BigO, that is f of n less than or equal to c of g of n. So this is n square plus n less than or equal to c into 5n square. So let's take c equal to 1. So n square plus n less than or equal to 5n square. If we take n equal to 1, this is 1 square plus 1, 2 less than or equal to 5. So the condition is satisfying. So c is greater than 0. Condition is satisfying. So now let's consider big omega. That is n square plus n greater than or equal to c into 5n square. So if you want to make this as greater, what we do? Let's take c is equal to half. Greater than or equal to half into 5n square. Okay, half can't be cancelled. So let's take 1 by 5. So 5 cancels, so n square plus n greater than or equal to n square. Here n square plus n. This is greater. So in this way we are proving big omega. So if as big O and big omega is satisfying, it is f of n equal to big theta of g of n. This is about big omega, big O and big theta. If you like this video, please do like, share, comment, subscribe and click on the bell icon so that you will get to know about the new videos notifications. Thank you.